have perfect coupling, it becomes a transformer. When you have perfect coupling between the inductors, it becomes a transformer. The way that I can identify that I now have that perfect coupling, which makes it a transformer, is it has those two vertical lines, right? It has those two vertical lines in between the inductors, okay? And now, N1 and N2 represent the number of turns. So I have N1 is 25 and N2 is 1. So that ratio, N2 over N1, is 1 over 25 for this circuit. And that means we have a step down transformer. That means I put in a bigger voltage than I get out. Any questions so far? Okay, there is one mistake on here though. Instead of 6 Henry, this should have been 6 millihenry. So please fix that. Instead of 6 Henry, this should have been 6 millihenry. So I know that my input is 25 cosine 1000 t. So omega is 1000 radians per second. Omega is 1000 radians per second because my input is 25 cosine 1000 t. Questions? So now we're going to draw the circuit in the frequency domain like we always do. So here's my time domain circuit. And here's my frequency domain circuit. There's no dependent sources this time. It's just ideal transformers. You don't have to add dependent sources or anything like that. So the voltage source is 25 angle 0 degrees. This inductor is J 6000 ohms. All right.
No, it's J6.
Maybe it was right. Nope. It's J6. No, it was right. It is a 6. My bad. Ah, so it was right. Sorry. It is a 6. Ignore me. Bad professor. So it is J 6000 ohms. For some reason, I was fixing that thinking it was wrong, but it's not. You're right. We got to make sure they're in the same multiplier. So it is 6 Henry. I was right the first time. So it is 6 Henry. So it's J 6000 ohms and 1500 ohms. And then I have V1 here and V2 here. Over here, this resistor is 4 ohms. And the capacitor is negative J 14.4 ohms. And I label this clockwise current here I1 and the clockwise current here I2. This is called the primary side of the transformer and the secondary side of the transformer. Primary's on the left, secondary's on the right. So there's two ways. Yes, Miguel. Yes, the side on the left with the voltage source is the primary. So there's two ways to do these problems. You can solve it like it is, or you can reflect the primary to the secondary. We normally do reflecting. So what I'm going to do, and I gave you the formula for these, they were right here. On page 4, if I want to reflect the secondary to the primary, then I use these formulas here. ZL prime equals ZL over N squared. V2 prime equals V2 over N. I2 prime equals NI2. I'm going to use these three formulas to reflect the secondary to the primary so I can write one loop and then solve that one loop equation. So the formulas I'm about to use are on page 4 of your notes. Questions? All right. So the primary side stays the same. So now I draw this one circuit. And everything that was on the primary side, I just copy it down. So I'll have J, 6,000 ohms, 1,500 ohms, and 25 with an angle of 0 degrees in volts. And then I still label V1 where it was. Okay. If I call this RL, this resistor is RL prime. That means RL reflected. If this is RL, this becomes RL prime, which means RL reflected. And if I call this capacitor ZL, then this capacitor becomes ZL prime. ZL becomes ZL prime when I reflect it. RL becomes RL prime when I reflect it. Any questions so far? So now I use my formula. RL prime equals RL over N squared. RL prime equals RL over N squared. So that is 4 times 625, which is 2,500 ohms. 4 times 625 is 2,500 ohms. Okay. Then ZL prime is ZL over N squared. And that's negative J 9,000 ohms. Negative J 9,000 ohms. So now this current is still labeled as I1, but now it's I1 through that whole loop. The clockwise current around that loop is I1. So I1 is equal to 25 angle 0 over J 6,000 plus 1,500 plus 2,500 minus J 9,000. I1 is 25 divided by those 4 impedances. $25 divided by those 4 impedances is I1. What is I1? Miguel? Okay, 5 with an angle of 36.87 degrees. Okay. Then V1 is the voltage across 2,500 minus J 9,000, those two in series. That's 2,500 minus J 9,000 times I1. V1 is the voltage across that 2500 in series with that negative J9000. So I1 times 2500 minus J9000. Think about it like a voltage divider. It's the voltage across those two to get that voltage right there in the middle. So what is V1?
$46,703. Angle negative 37.
Very good. 46.7 with an angle of negative 36.6. We're off by a multiple somewhere.
46,700.
Yeah, this is milliamps. Sorry about that. This should have been milliamps because this ends up being volts.
Okay.
Sorry about that. So it's 5 with an angle of 36.87 degrees. That's milliamps. So V1 is 46.7 with an angle of negative 37.6 degrees. Okay. So the last two values we need are V2 and I2. The way you do that is because I1 and I2 enter at the dots, on those two transformer sides, the formulas are V2 is negative in V1. Remember, the signs are dictated by whether it enters or exits the dot. So if we go, one's positive and one's negative, so that's why you use the minus sign on that. And then for the current, because they both enter, that's why I use the negative on this. Okay. So I am about to pass out your exam sheet. I want you guys to find V2 and I2 using the formulas. V2 is negative in V1, and I2 is negative I1 over N.